When we constructed dot plots and stem and leaf diagram, the data set was numerical. What are the graphical tools for representing the categorical data? Let us consider example, and based on that example we will overview the graphical tools. Well, as I mentioned, I work for medical device manufacturer, and I spend a lot of time in manufacturing floor, and naturally we collect data on the rejects and the yield loss, and would like to improve our yields. So this is a typical reject summary of one of our product lines. So let's build our data set together. So we have a category and count. Okay, so those are the reject categories. As I mentioned earlier, I work for medical device manufacturer, and we manufacture a lot of catheters. The nature of catheters implies that they could be easily kinked. So we have rejects for kink. On a weekly basis, we counted 221 catheters rejected for kink. There are some rejects for surface defects, surface discoloration. There were 167 of them. Because of the high humidity, we observe bubbles on the surface during reflow process. So there were 267 catheters rejected for that purpose. We assemble catheters using the braiding process also. So when braid is visible, we do not consider those catheters as acceptable, because they can potentially damage the vessels. So we reject those catheters as well. So we have braid visible, reject category, and we rejected 101 catheters for that. Naturally, we test destructively some of the catheters to ensure that we still have a good manufacturing process. So for that particular week, for destructive testing, we utilized 50 catheters. So one of the ways of graphically representing categorical data is called pie diagram, where actually the name speaks for itself, where a diagram in the form of the pie has certain slices which represent the percentage of each category. In this case, 221 is, I just did some math before, it's a 27.4% of the entire data set of the rejected catheters. Surface discoloration is it's a 20.4%. Bubbles on the surface it is 33.1%. Braid visible is 12.5%, and destructive testing is 6.2%. So we cannot do anything with reducing destructive test because it's necessary for assuring that our process remains strong and good. But we could certainly do a better job on reducing other reject categories. So, and based on those reject categories, we have basically 6.2%. That's the destructive test. Then we have 12.5%. That's the braid visible. Okay, then the rest we could divide almost. Then 33% would be bubble surface, a bubble on the surface. Bubble on the surface. Then 27% kink. And 20% surface discoloration. So that's this representation is called pie chart, and certainly the coloring is applied as well. The statistical software do this job perfectly. I just did for presentation purposes. Another way of presenting the categorical data is called bar chart. Instead of pies, one graphs the bars. And the height of the bar is related to the frequency. So the highest bar in this case will be bubble on the surface, which is 33%. Then the second highest bar will be kink. Then surface discoloration, braid visible, and destructive testing. So certainly the improvement projects should concentrate on highest contributors. In this case, perhaps it's a good idea to start the project on reducing the bubble on the surface defect and kinks. So this much is about graphical representation of the categorical data. Okay.